Everybody, hope you're doing well. This is going to be a video on our section 1.2, which is about measuring and constructing segments. We're going to skip ahead down to page 9 in your journal. And now we're going to do a little bit of vocab for a second. Some of these words we will have in our interactive vocab dictionary, but the first two up here I just want to touch on for a minute. A postulate and an axiom. I think it's just important you just at least recognize what they are. But postulate and axiom, these are words that are used a lot in mathematics. And I'm not going to say too much about them because personally I don't feel like they're the most important things in the world. But you might hear them come up. So postulate and axioms, these are just the quickest way to say them, and if you want, you could write that down. These are just statements or facts that are taken to be true without any proof whatsoever. Basically, it's just they're the foundation of mathematics. So that's what they are. These are some statements or facts that are taken to be true. We can't necessarily prove it, but we're using them. Okay, so these are just like, basically they come down to being facts that we know are true without having to do any other proof or reasoning. Okay, so we'll see what those mean, and we'll explain it in some context if we have to. I'm not showing my face on this one only because I'm trying to see if it'll make me write a little bit better. Maybe the computer was doing too much last time. So coordinates, distance, these things should all be defined for us on our interactive dictionary. So the ruler postulate, I mean, this is just an example. The points on a line can be matched 1 to 1 with real numbers. It's not really that important, but it's just something that we can. It's just more of a counting thing. So don't worry about that. But we see a coordinate of a point. So coordinates, a lot of times we think of a number line. Different points on the number line, those are called coordinates. So we can say that a number is at 5, right? That means it's 5 units on the number line. And then the distance between points A and B. Now there's a phrase that we just throw in here and kind of take for granted, but do we know what the words absolute value mean? So absolute value is just really the distance. It's just really the distance that numbers are from 0 or things like that. Yeah, just from 0. It's just one way to measure space mathematically. Okay, so that's really what we're looking at. Absolute value. All that is saying is, if you know, for example, that point A is at position or at 6 and point B is at 13, okay, logic says that the distance between 6 and 13, or the distance between A and B, that's 7, right? Because you can just count the units. 1, 2, 3, 4, 5, 6, 7. If you just do what they're saying here, you go x2. So you can either do it like this, 13 minus 6 to get 7. Or if you do 6, that's an equal sign. If you do 6 minus 13, well, what are you going to get? You're going to get negative 7, right? So if you do that, you have to use absolute value because distance is not negative. You would never tell me that Cuyahoga Falls is negative 100 miles from Columbus, right? You would just say it's 100 miles from Columbus, or Columbus is 100 miles from Cuyahoga Falls. It doesn't really matter. So there's no negatives to it. That's why we take the absolute value. So that's all it's saying, is that just this basically distance should always be positive. Is positive, always positive. Okay, so let's look into a couple things here. Congruent segments, line segments that have the same length are called congruent segments. So that's all it means, is they just have the same length. And in general, Congruent means they have the exact same shape and size. And we can be talking about triangles. We can talk about all kinds of stuff. But congruent just means the exact same shape and size. So segment AB is congruent to segment CD. And this little tick mark right here, which is something we saw in Desmos the other day when we were doing like the polygraph where you had to try to match or have your partner guess what your graph is. These little tick marks right here. These tick marks mean that these two segments are congruent and that they have the same length. So when we say lengths are equal, we write AB is equal to CD. If we say segments are congruent, so the shape, we write the segment bar and we use this symbol right here. It's an equal sign with a little tilde over it. And that stands for congruent. The real difference here comes down to a little bit of mathematical discussion and notation. Really, congruent means you can. Here's what congruent means. I can put segment AB exactly on top of segment CD. Like I could literally just take AB and slide it down. It would match and lay right on top of CD. The length just means, maybe I'm going to type this one here. I think that might work a little bit better. So for the lengths being equal, all that means is if I measure AB and CD, then I get the same measure or length. Okay, that's all that means. So one's talking about measuring when we say it here, and the other one's talking about just like sliding it on top of the other one. So here's a postulate, example of postulate. I'm not too worried about if you remember all the names of these postulates, but what is important is that you understand what this is saying. So so postulate 1.2, segment addition postulate. Okay, don't worry about the name. What does that actually mean? Let's put it, it says if B is between A and C, then AB plus BC equals AC. Great, good stuff. Here's all that means. Draw yourself a segment. Okay, so here's your segment. For kicks, we'll label them A, B, and C, just like the picture up there. Here's all this means. If AB is 10 and BC is 5, I'm sorry, this is glitching so bad. I really thought this would go better. That's 5. Then, so if we got 10 from here to here, there's 10 from A to B. And then from B to C is 5 more. All that means is if you go A all the way to C, we will just get 15. That's all it is. That's all it's saying. Segment addition. You just add 10 plus 5, you get the whole thing. A, B plus BC is the whole thing, 15. That's all it's saying. So just add those two together, and bam, you got the whole bit. So 10 plus 5 is 15. That's all it's saying. That is what you need to know. I don't really care if you remember. It's called the segment addition postulate, but you just need to understand that you can just add those together. All right. So plot the points. This is some point plotting. I'm not going to do all of these, but we're going to look at a few of them here. So maybe we'll do number 1, and I'll leave you to practice a couple of these. and then determine whether the segments are congruent. So let's plot some points here. So first, you need a grid. You have a grid. You need some axes. So we'll call that our y-axis, right? Ooh, those are bad. Bad lines, bad lines, bad lines, bad lines, bad lines. I may have to transfer, next time I do this, transfer this over to, wow. Transfer this over to something that I have that probably won't glitch as badly. So just bear with me. I'm leaving this on Loom. You can double the speed if you'd like, or time and a half or something. It'll move it along a little faster. So sorry about that. Okay, so point A is -5. So you start at 0, you go -5, 5. There's point A. Point B is -2, 5. So -2, 5 is there. So this is segment AB right there. And then 2, -4. So 2 to the right and -4. That is point C. And then D is -1. So left one, and then down to 4. That's point D. So the question is, are AB and CD congruent? That's all we want to know. So what does it mean if they're congruent? That means that they have to have the same length. They have to have the same length. So this is our question. I want to know, are they congruent? Well, what's the length of AB according to what we drew here? Well, if I just count the blocks, 1, 2, 3, it's 3. CD, 1, 2, 3. Okay, yes. Yes, yes, yes. They are congruent because they have the same length. Okay, so that's all you're going to check here. You're just going to plot those points and you're just going to count, are they the same length or not? If they have the same length, they are congruent. If they don't have the same length, they are not congruent. Okay, find VW. So applying some of what we know here. So if the whole thing, this whole segment from V to U is 31, and this piece is 8, well, if you just take 31 minus 8, get 23. So this piece right here, VW, that one right there. Oh, let's keep going. Stop. Stop, stop, stop. From V to W is 23, okay? And the same thing goes here, V to W. So if I know this is 45, so VW is this whole segment. That's 45 and that's 30. That whole thing should be 45 plus 30, so that is 75. That is the length. Stop. VW, okay? And then finally, we have this little application here. Bookstore and movie theater are 6 kilometers apart along the street. We have a florist is between the bookstore and theater. So let's say B is bookstore, T is theater, and the florist, let's see. So we have sort of a segment right on the same street. So that's T. We know that whole segment is 6 kilometers. And it says the florist is 2.5 kilometers from the theater. So the florist is probably somewhere in here. Then we know that's 2.5. So then the distance from the florist to the bookstore is just logically thinking that I got to go all 6 kilometers from the bookstore to the theater. 2.5 of them is from the florist to the theater. So if you just take 6 and subtract 2.5, you will get this distance right in here. And that is 3.5. You have to put units on there. 3.5 kilometers.